Hello, students of grade 9. This is a new mathematics lecture in semester 2. It is lecture 3, and the title, as you can see, is again lines and coordinate system. This is part 2 of our lesson. We are done with part 1 in lesson lines and coordinate system, and today I will start with you part 2. The objectives of our lesson: number 1, we will learn how to find the coordinates of the midpoint of a segment in a system of axes. Objective number 2, determine the equation of a straight line in 3 cases. Case 1, we will learn how to determine the equation of a straight line passing through a given point of slope to be determined. Case 2, determine the equation of a straight line passing through a given point and parallel to another straight line. Case 3, the equation of a straight line passing through a given point and perpendicular to another straight line. So these are the objectives of this week. First, I started my session remembering you or reminding you of particular straight lines that we talked about. The first particular straight line is the general form of a straight line. So any straight line should be written in this general form, which is y equal ax plus b. The second straight line is a straight line which is passing through the origin. It has an equation y equal ax. Objective number 3, the equation of a straight line which is parallel to x-axis is y equal k. Of course, k is the ordinate of the given points we are locating in the system of axes. Equation number 4 is parallel, a straight line which is parallel to y-axis, which has the equation x equal k. Of course, k is the abscissa, the same abscissa of the given points. Now let's recall together 2 important rules that we learned in the previous lecture. In the previous lecture, we have learned how to determine the slope of a straight line passing through 2 given points. So a straight line passing through 2 points A and B have a slope which is slope of a straight line AB is equal YA minus YB over XA minus XB. Again, YA is the ordinate of A minus the ordinate of B over the abscissa of A minus the abscissa of B. So this rule, we use it always to determine the slope of a straight line passing through 2 points A and B. Also, we learned how to find the measure or the length of a segment, or we call it a distance. We have seen that after locating 2 points in a system of axes, we get a segment, and any segment we can determine its measure or its length. So given 2 points A, which has XA and YA, point B, which has XB, let me correct this, sorry. This is a typing mistake. So let me correct it. So it should be XB. So this is B, of course. If I'm writing the coordinates of point B, they should be XB and YB. Again, sorry for this typing mistake. So B is XB, YB. To find the measure of segment AB, we use the following rule. Always AB is equal to radical, big radical. First, we start with the big radical. XA minus XB, all of it squared, plus YA minus YB, all of it squared. Of course, I might be finding the measure of a segment other than AB. Suppose here we have EF, so it will be XE minus XF, YE minus YF. So the name of the points, of course, can change. Now, I will solve with you an exercise. Given the 2 points E and F such that E has abscissa 3, ordinate -1, and F has an abscissa I can't see this. Let me take it away. So F has an abscissa 5, -5, and an ordinate 5. First question, we should locate E and F. So let's locate E, which is a 3 - 1. So it has abscissa 3 and ordinate -1. If I draw a horizontal line and a vertical line, they will intersect here. So this is point E. This is how we locate a point in a system of axes. F has -5 and ordinate 5. So I go to the -5 on the abscissa axis. This is the -5. On the ordinate axis, I go to the +5. Also, I draw a vertical line, a horizontal line where they intersect. I get point F. So this is how we locate the 2 points E and F. Now in part 2, we should find the slope of the straight line passing through E and F, or we call it a straight line EF. So here we use the rule of the slope. So we write slope of line EF is equal YE minus YF over XE minus XF. So always we should memorize the rule of how to find the slope of a straight line in a system of axes. This rule should be memorized. Now we should replace, of course, YE is -1, so I replace it, minus YF is 5, XE is a 3, minus, since XF is -5, I replace it between parentheses. Now -1 and -5 is -6, 3, negative times negative is +5, so -6/8, I reduce my fraction, it becomes -3/4. So the slope of straight line EF is -3/4. Now we should calculate segment EF. Also here we have a rule. EF is equal to big radical XE minus XF all of it squared plus YE minus YF all of it squared. Now we replace the abscissa of E, which is XE is a 3, so I replace it by 3, minus XF is -5, so I replace it between parentheses because we have a negative and a negative after each other's, all of it squared, plus YE is -1, I replace it, minus YF is 5, all of it squared. Now I should get rid of this minus and minus after each other. I multiply them, negative times negative is positive, so I write a big radical, 3 plus 5, all of it squared, plus -1 and -5 is -6, all of it squared. Now 3 plus 5, its answer is 8, all of it squared, plus -6 squared is 36, because a negative base to the power squared, it becomes positive. 8 squared is 64, so 64 plus 36 is radical 100. Here, the answer of the radical should be simplified, as I taught you before. 100 can be written as a perfect squared, 10 squared, so the squared cancels the radical, then the measure of EF is 10. Please, this exercise, solve it again to practice all we learned in lecture 1. This is most of the important things that we learned together in lecture 1. Now, I will move to our lesson. In our lesson, let me erase this. So I will use the eraser. Now, in our lesson, coordinates of the midpoint of a segment. So after drawing a segment in a system of axes, any segment has a definite or a known length. So the midpoint of a segment can be determined or found. What do we mean by midpoint? It is a point at the middle of a segment. So in a system of axes, the segment has 2 points. Each point has an abscissa and an ordinate. So after drawing a segment in a system of axes, the segment will be between 2 points. The first point has an abscissa and an ordinate. The second point has an abscissa and an ordinate. So the midpoint in a system of axes has also an abscissa and an ordinate. For example, if I gave you point 1, A, B, C, D, whatever its name, it has an abscissa 1 and an ordinate 1. Also, point 2, it has any name, it has abscissa 2 and ordinate 2. To find the coordinates of the midpoint of point 1 and point 2, these are the rules. The first rule is how to find the abscissa of the midpoint. The second rule is how to find the ordinate of the midpoint. So the abscissa of the midpoint, we call it x midpoint, is equal to x of the first point plus x of the second point, the abscissa of the first point plus the abscissa of the second point over 2. Why over 2? Because it is in the middle. Anything in the middle, we divide it by 2. So this is the rule of the abscissa of midpoint. These should be memorized. So x of the midpoint, or the abscissa of the midpoint, is equal the abscissa of the first point plus the abscissa of the second point divided by 2. Also, the ordinate of the midpoint is equal the ordinate of the first point plus the ordinate of the second point divided by 2. So from here we get the abscissa of the midpoint. From the second one, we get the ordinate of the midpoint. Now I will do with you an exercise. Given the 2 points A and B such that point A is minus 5, 1, point B is 1, minus 3. Let us locate the 2 points A and B here in the system of axes. So negative 5 abscissa, this is the negative 5, I located. The 1 ordinate, this is the 1 ordinate, I located. Of course, I draw a vertical line, a horizontal line. Where they intersect, I get point A. Now, point B is 1, negative 3. It is 1 abscissa and negative 3 ordinate. I draw a vertical line, a horizontal line. Where they intersect, I get B. So this is point A and this is point B. Here I can get a segment AB. So if I join A with B, I will get a segment AB. Now, let M be the midpoint of segment AB. We should find the coordinates of M. So he is telling me that the midpoint of segment AB is called M. We should find the coordinates of M. We start like this. M is the midpoint of segment AB. So what does the rule say? XM, or the abscissa of M, is equal the abscissa of A, which is the first point, plus the abscissa of B, the second point, over 2. Let's replace the abscissa of A is minus 5 plus the abscissa of B is 1 over 2. Now minus 5 plus 1 is minus 4 over 2, which is minus 2. So this is the abscissa of the midpoint. Now we will get the ordinate of the midpoint. YM is equal YA plus YB over 2. Let's replace YA by 1. Here I have also sorry for these mistakes, typing mistakes. So YA is 1. Let me erase these. YA is 1 plus, what is YB? YB is negative 3. So this is negative 3. Now, positive times negative is negative. So I will get 1 minus 3 over 2, which is minus 2 over 2, and minus 2 over 2 gives me minus 1. So this is, please don't care about it, okay? So 1 plus negative 3 is equal to, this is negative 3. It is equal to 1 minus 3 over 2. So the ordinate will be minus 1. So M will have an abscissa minus 2 and an ordinate minus 1. Let us locate M, because here I'm asked to locate M. Please remember, after you finish finding the abscissa and the ordinate of the midpoint, you should write it like this. It is named M, it has abscissa minus 2, and it has ordinate minus 1. So let's locate it here. It is minus 2 abscissa, it is minus 1 ordinate. If I join both by a vertical line and a horizontal line here, I get M. So M is the midpoint of segment AB. Now, if you join AB, M, of course, will be on the midpoint of segment AB. Now, equation of a straight line. Again, let me erase what's written here. Now we will find the equation of a straight line. As you remember from the objectives, we have 3 cases of equations of a straight line in a system of axes. Case number 1, equation of a straight line passing through a given point of slope to be determined. So this straight line will pass through a given point, a point that I will give you its abscissa and ordinate, and you should determine its slope. How do you determine the slope? Of course, as you remember, we have a rule to determine the slope of a midpoint, of a straight line. So here we'll be having 2 points, the first point with abscissa and ordinate, the second point with abscissa and ordinate. What are the steps to do this or to find this straight lines? Please, these steps are very important to follow. Step number 1, we find the slope of the straight line, of course, using the rule that we learned before. Step number 2, we take any of the 2 given points, either point 1 or point 2, and we replace its coordinates in this equation. Please, we should memorize this equation. From where did I get it? I get it from the equation of the slope. So y minus y1 equals slope into x minus x1, or y minus y2 equals slope into x minus x2. Again, what do we mean by y1 and x1? The abscissa and ordinate of the first given point. You can use either this or this. If you use any one of them, you will have the same answer. I have written both in front of you to see that you will get the same answer. Now I will solve with you an exercise. Given the 2 points, A, which is 4, 3, B, which is minus 1, 2. We should find the equation of a straight line AB. As the steps say, we should find first the slope of a straight line AB. So to find the slope, we use the rule. Slope of AB is YA minus YB over XA minus XB. Now I replace YA 3 minus YB is 2 over XA is 4 minus XB is minus 1, so I replace it between parentheses. Now 3 minus 2 is 1, minus times minus is plus 1, so 1 over 5. This is the slope of a straight line AB, which is 1 over 5. Now the second step, we take any of the 2 given points. Either we take A or B. Now I will show you the 2. If you take A, what will be your answer? If you take B, what will be your answer? You will get the same straight line. Let me take A and replace it in this equation. So A, I say A belongs, we use for it from now on this symbol. This symbol means belongs. So point A belongs to line AB. It belongs, why? Because it's called AB. So of course A is on AB. Then I will write this equation here. Y minus YA equals slope into X minus XA. Now I replace YA and XA and the slope. So Y, I keep it as it is, and X, I keep it as it is. I replace YA, slope, and XA. Y minus, what's YA? It is a 3 equal, the slope is 1 over 5. So 1 over 5 into X minus, what's XA? It is 4. So I replace, now I make it looks like a straight line. So I get, this is the equation of a straight line AB. Suppose I take B belongs to straight line AB. If I take the second case, I will replace Y minus YB equals slope into X minus XB. So now I take the coordinates of B and I replace them here. So Y minus 2 equal 1 over 5. This is the slope into X plus 1. So I will manage the form of this equation. Y is equal to, I multiply 1 over 5 by X, it's 1 over 5X. I multiply 1 over 5 by 1, it's 1 over 5. I take minus 2 to the other side, it becomes plus 2. Now, as you can see, In both, I get the same equation of a straight line AB. You shouldn't do both. You can choose one of them and write the equation of straight line AB. Now, case number 2, the equation of a straight line passing through a given point, but it's parallel to another straight line. So if two straight lines are parallel, this is a very important rule. So if you're given any two straight lines in the system of axes, they are parallel to each other, there's a rule which say slope of line 1, slope of the first line will be equal to the slope of the second line. So the two lines that are parallel will have the same slopes. Given a straight line D, which is y equal 3x minus 4, and we have a point A, which is minus 2, 5. We should write the equation of a straight line L. What's L? Such that straight line D and L, which I should find, will be parallel and L passes in A. Let us start with L and D are parallel. What does D and L are parallel mean? They have the same slope. So what should we write? Since D and L are parallel, then the slope of D is equal to the slope of L. If we look at D, this is the slope. It is the number multiplied by X. So the slope of D is 3. Then the slope of L will be how much? 3. I found the slope. Now from the question, I see that L passes in A. Then A belongs to L. I write A belongs to L. Then Y minus YA equals slope into X minus XA. Now I replace the coordinates of A here and the slope, which is 3. So Y minus 5 equals 3 into X plus 2. Then Y is equal to 3x plus 6 and minus 5 is taken to the other side. So Y equals 3x plus 11. This is the equation of a straight line L. As you can see, the slope here is equal to the slope of straight line D. They have equal slopes. Now, how can I verify or check if a point, if I give you a point that it belongs to a straight line? To verify or check if a given point belongs to a straight line, the coordinates of the given point must satisfy the equation of the straight line. So what do? We replace the coordinates of the given point in the equation of the straight line. After that, both sides should be equal. For example, I'm asked, does the point A, which has 1 minus 4, belong to D? I don't know. I take the equation of a straight line D and I replace the abscissa and the ordinate in the Y and the X. So we say, let's replace the coordinates of A in straight line D to see if they satisfy. YA. So here, Y, I write it YA, is it equal to 2XA minus 1? They are not equal till now. I should check if they are equal. So let me replace YA by minus 4. Is it equal to 2 into 1 minus 6? Now, are these two equal to each other? Minus 4, is it equal to 2 minus 6? I don't know. Minus 4, is it equal to 4? Yes, this is true. Because the two sides of the equation are equal, they satisfy the equation. Now I say point A belongs to straight line D. The third case, the equation of a straight line passing through a given point, but perpendicular to another straight line. So here I will have two straight lines perpendicular to each other's. The rule says if two straight lines are perpendicular, then the slope of the first straight line times the slope of the second straight line should be equal to minus 1. Given a straight line D, which is y equal 3x minus 4, and a point A, which is minus 2, 5. What should we do? We should write the equation of a straight line L such that D and L are perpendicular and L passes in A. First, I should determine the slope of L. Here I have a rule. The slope of D times the slope of L is equal to -1. Why? Because they are perpendicular. So we say D and L are perpendicular, then the slope of D times the slope of L is equal to -1. What is the slope of D? The slope of D from here, it is a 3. Now let's multiply the slope of D times the slope of L is equal to -1. I replace the slope of D by 3. I will determine the slope of L. So the slope of L is equal to -1 over 3. If I take the 3 to the other side, it becomes over 3. So this is the slope. Now I know that L passes in A. Then I say A belongs to L. Then Y minus YA equals slope into X minus XA. Y minus YA is 5 is equal to -1 over 3 into X plus 2. Why is it plus? Because here we have -2 and we have minus. So negative times negative is positive. So I will manage the form of this equation and I will get the equation of L, which is Y equal -1 over 3X plus 13 over 3. Now I will do a practicing with you. Are the two straight lines D and D1 parallel? The slope are two straight lines to be parallel, their slopes should be equal. Let's take D. So D and D prime are parallel if their slopes are equal. What is the slope of D? The slope of D is 5. What's the slope of D1? It is also 5. So since the slope of D is equal to the slope of D1, then D and D1 are parallel to each other. Are the two lines D and D1 perpendicular? I ask myself. D and D1, when are they perpendicular? They are perpendicular if we multiply the slope of the first line by the slope of the second one, I should get a -1. So we say D and D1 are perpendicular if the slope of D times the slope of D1 is equal to -1. What is the slope of D? It is a 3 over 4. This is the slope of D. It is everything multiplied by X or before X. Now the slope of D1 is -4 over 3. Now let's multiply the two slopes. The slope of D times the slope of D1. So 3 over 4 times -4 over 3, it is -1. So since the slope of D times the slope of D1 is equal to -1, then the two straight lines D and D1 are perpendicular. Please listen to me carefully, my lovely students. What I discussed today is not at all difficult. These are only rules. You know the rule, you can apply the rule. You memorize the rule, you can apply the rule. So please, after watching this video, write notes as we usually do, the important notes in the lectures, all the rules in the lecture, and study them, and everything will be easy. So this was our lecture for this week. Watch the video well and meet you on Zoom soon.